Number 2, gases. Number 3, liquids. Number 4, solids. And then, end na sa ating lecture. Okay, now let's talk about the first area, the binding forces between in molecules. Now, there are two types of attractive forces in molecules. We have intra and then intermolecular forces. Intermolecular. So, how would you differentiate the two? Pag sinasabi nating intra, it is the force that holds the atoms together. For example, sa isang compound, let's say we have the compound HCl. The force between hydrogen and chloride, it is what we call as your intramolecular bonds. So between two atoms. However, when we say intermolecular bonds or forces, it is the force that acts between molecules. So for example, may isang HCl na molecule dito and then another HCl molecule. The force that holds two HCl molecules are what we call as your intermolecular forces. Intra, between, intra pala, within, inter, between molecules. Okay, so for a shortcut pala, inter, it is the force found between molecules, intra, found within molecules. So yung color blue, that's the intermolecular force. Yung naka-color yellow, intramolecular force or bond. Okay, so next we have the manifestations of your intermolecular forces. There are two. We have adhesion and cohesion. When we say adhesion, attraction between unlike molecules, like nandito sa baba, attraction between water and then the molecules of the glass tube, kung asa siya ni rise up, adhesion. Whereas cohesion, it is the attraction of like molecules. Itong nasa baba, it's an example of a cohesive or cohesive force kasi yung liquid attracted lang sa liquid na nasa baba, na nasa bulk. Adhesion, unlike, cohesion, like molecules. Alright, now there are two types of forces as mentioned earlier, intra and then inter. Now, I'll give the different types of intramolecular forces. There are two main types of intramolecular forces. Meron tayong covalent bond at saka ionic bond. Covalent bond, ionic bond. How to differentiate the two? Pag sinasabi natin covalent, it involves the sharing of electrons. Ionic bond, it involves the transfer of electrons. Covalent, sharing, ionic, transfer of electrons. Now, how would you differentiate the two of them based lang sa structure sa ating chemical formula? So actually, may palatandaan lang talaga tayo. When we say, or rather, when we identify a covalent bond, just remember lang that a covalent bond occurs between a non-metal and another non-metal. For example, carbon, oxygen, sulfur, oxygen. So any type, the force or bond between two non-metals, ang tawag natin dyan, covalent bond. However, for an ionic bond, it's a type of bond between a metal atom and a non-metal atom. Like for example, sodium, chloride. Sodium, it's a metal. Chlorine is a non-metal. So therefore, the attraction between the two, metal and a non-metal, ionic bond. Covalent bond between non-metals, ionic, metal, and non-metal. Now, furthermore, Sa covalent bond natin, meron tayong dalawang types or subtypes. We have polar covalent bond and non-polar covalent bond. Pag sinasabi nating polar, it involves the unequal sharing of electrons. Non-polar, equal sharing of electrons. Nangyayari ang unequal sharing of electrons because there are some atoms na electronegative, kung saan i-attract niyang electrons towards itself. So, ang mangyari, ang isang side, sobra ng electrons, yung isang side, konti lang ang electrons. So, polar covalent bond, unequal sharing, polar covalent bond, unequal, non-polar, equal sharing of electrons. Okay? So, a review of the periodic table. So, itong stairs dito, itong color yellow, this is the metalloids. The one on the left side, mga metals natin yan. The one on the right side, those are our non-metals. So if you're able to identify if it's a metal or a non-metal, malalaman ninyo if it is a covalent or an ionic bond. Okay? Sige. Let's have an activity. Di siya legit ha. Okay, so ang question here is that identify the intramolecular force present in the following. So, first one, what is holding the ions together in your cupric chloride? So, obvious naman siya from the name itself, ions. Tapos, ang compound itself, metal, non-metal ito. So, therefore, this is an example of an ionic bond. For number 2, what is holding the atoms together in an HF molecule? H is a non-metal, F is another non-metal. However, ang F, it is an electronegative. So, i-attract niya ang electrons towards itself. So, therefore, it is not simply a covalent bond, but it's an example of a polar covalent bond. And then number 3, the last one, what is holding the atoms together in the chlorine gas? Tandaan natin pag mga diatomic na molecules, diatomic, kanang tigduha sila, O2, Cl2, I2, etc. Those are examples of your compounds that are bonded via non-polar covalent bond. So therefore, number 3 is an example of a non-polar covalent bond. Okay, so yan siya for our intramolecular forces. Polar covalent, non-polar covalent, ionic. How about for your intermolecular forces? Your intermolecular forces, these are the forces found between molecules. Now, there are 4 types of intermolecular forces. This is the first example or first type of intermolecular force. This is your van der Waals forces. Van der Waals forces, we have 3 subtypes: dipole-dipole, dipole-induced dipole, and then induced-dipole forces. The other names are located on the right side. Ang dipole-dipole, sub, ang dipole-induced dipole, Debye, ang induced dipole, London, or dispersion forces. Now, you may wonder, ano ba ang ibig sabihin natin ng dipole at saka ng induced dipole? What do we mean by this? Pag sinasabi nating dipole, it refers to a polar molecule. Polar molecule. Pag sinasabi nating induced dipole, it refers to a non-polar molecule. Therefore, para makaproceed kaya sa intermolecular force, para maintindihan ninyo, dapat mas naintindihan niyo muna yung previous topic about the polar covalent and then the non-polar covalent bond. Okay? Again, ang dipole, polar, induced dipole, non-polar. Therefore, kung dipole-dipole forces siya, it's a polar molecule attracted to another polar molecule. Okay? Next, the second type of intermolecular force, we have ion dipole. The third type, we have the ion-induced dipole. And then the fourth one, we have hydrogen bonds. So, muna silang upat ha. These are the four types of intermolecular forces. So, dipole versus induced dipole. So, to give you an example, what is an example of a dipole? Again, dipole, polar molecule. Chlorine is much more electronegative compared to hydrogen. So, i-attract niya ang electrons toward itself. So, it becomes a polar molecule. On the other hand, pag mga diatomic gases, kapag mga tigduha good, those are examples of non-polar molecules. So kapag dipole, it refers to a polar molecule, induced dipole, non-polar molecule. Okay? So to describe further the different types of intermolecular force under van der Waals forces, we have first one, your dipole-dipole. Again, dipole-dipole are example. It's also known as your key-sum forces. Other name, it's also called the orientation or the alignment effect. So again, dipole-dipole, it is the attraction between two polar molecules. The energy of dipole-dipole force, it's 1 to 7 kcal per mole. 1 to 7 kcal per mole. Next, after dipole-dipole, we have the dipole-induced dipole. It's also known as your Debye forces or the induction effect. So again, it's the attraction between a polar and a non-polar molecule, between polar and non-polar. So the energy, it's around 1 to 3 kcal per mole. 1 to 7, 1 to 3. And the last one, we have your induced dipole forces. The other name, it's London dispersion force or simply dispersion effect. It's the attraction between two non-polar molecules. The energy, it's around 0.5 to 1 kcal per mole. 0.5 to 1. So kung ikumpara mo good between the three of them, the weakest would be the dispersion effect. So kung weakest, dali siya i-break. Dali siya mag-change o state from one state to another. From solid to gas, from gas to solid, etc. Okay? So yan siya. Let's have an activity. The question here is, what type of intermolecular force is present in the following scenario? For number 1, what is holding two Br2 molecules? Again, Br2, diatomic gases, they are non-polar. So kapag dalawang non-polar, this is what we call as your London forces or the dispersion effect. Dalawang non-polar London forces or the dispersion effect. On the other hand, what is holding two OF2 molecules? OF2 is an example of a polar molecule. Because of the presence of fluorine, which is electronegative, so i-attract niyang electrons towards itself. So magiging polar siya. So kapag dalawang OF2, dalawang polar, it is what we call as your key-sum forces. Key-sum forces or the orientation, or the alignment effect. So, ganun lang. Pag-identify for intermolecular forces. Okay, next, the second type of intermolecular force, kasi kanina it's only van der Waals. Tatlong subtypes tayo for van der Waals. For this one, the second type of intermolecular force, it's the ion-dipole interaction. The best example of an ion-dipole interaction is when ionic crystalline substances are dissolved in polar solvents. Like for example, salt in water. This represents the ionic crystalline substance, the NaCl, dissolved in a polar solvent, your water. It's an example of an ion-dipole interaction. Yan lang for the second type of intermolecular force. The third type of intermolecular force, it's your ion-induced dipole interaction. The best example here, it's the formation of the potassium triiodide complex. Ang iodine kasi itself, it is insoluble in water. That is why usually gina-add siya ng solubilizing agent like your potassium iodide or sodium iodide to form the triiodide complex. Itong triiodide complex, itong Ki3, it is soluble in water na, unlike your iodine itself. So the interaction between the two, it's what we call as your ion-induced dipole interaction. Okay, this is the ion, this is the induced dipole. Ano siya, ang I2, the non-polar. Okay, and then the last type of intermolecular force, it's your hydrogen bond. Hydrogen bond has an energy of around 1 to 8 kcal per mole. So stronger siya. 1 to 8 kcal per mole. Hydrogen bond, it's the attraction of hydrogen and a highly electronegative element, either fluorine, oxygen, or nitrogen in a molecule. So again, those are the four types: van der Waals, ion dipole, ion-induced dipole, and hydrogen bond. Okay, so that's it for the first part, the types of forces. So before we proceed to the second type, let me first give you a review about the following. First one, the physical properties of systems. When we say system, it is a bound space on a definite quantity. Now, there are three types of physical properties, which will be expounded pa talaga later. So the first three types are as follows: additive, constitutive, colligative property. When we say additive properties, these are properties that depend upon the sum of the individual properties of the components present in the system. An example of an additive property would be your molecular weight. Okay, di ba, para i-compute nimo ang molecular weight, you need to account for the individual atomic weights. Tapos i-add nimo sila para makuha nimo ang molecular weight. So that's an additive property, the molecular weight. Constitutive property, these are properties that depend on the type and the arrangement of the components present in a system. Examples of your constitutive properties are refractive index and the optical properties. Constitutive property. The last one among the three, your colligative property. Colligative property, it's a property that depends on the number of the components present in the system. Pila ka buok ang present sa system. Colligative property. Colligative property will be expounded to you later on under liquids. So those are the first three physical properties: additive, constitutive, colligative. Next, expounded pa siya further to 5 types of properties. The fourth one, we have extensive, also known as your extrinsic property. When we say extensive or extrinsic, this is a property that depends on the size or amount of materials in a system. Like for example, volume, mass, weight, or heat content. So this is a property that depends upon the size or amount. So for example, volume, if you add 4 ml of solution A with another 4 ml of solution B, it will become 8 ml. So nagdepende siya sa size or amount. On another note, intensive or intrinsic property, these are properties that do not depend on the size or amount or kind of material in a system. Examples are boiling, melting, freezing points, pH, pressure, temperature, etc. For example, if you add 4 ml of 100 of a liquid that will boil at 100 degrees with another with 4 ml of another liquid that will boil at the same temperature, although ang kanilang volume maging equal to 8 ml, pero overall, ang kanyang boiling point will still be at 100. Okay? So, boiling point, intensive property. Okay? Next, we have the next one, density, specific gravity, and specific volume. Density in pharmacy, it is described as grams per ml or mass per unit of volume. And then there are 3 types of density as mentioned in the book. We have absolute, apparent, relative density. So by definition, when we say absolute density is a type of density that is measured in vacuum. Apparent, measured in air, and then relative density, it is measured in a specific or given condition. So just remember lang the definitions. For absolute, in vacuum, apparent, in air, relative, in a specific or given condition. Okay. Next, we have your specific gravity. Specific gravity, it is the ratio of a mass of a substance to the mass of a given standard. So usually, specific gravity, it is usually interchanged with your density. Pero ang specific gravity kasi, usually, para pag-compute nito, you need to compare it with a standard. So another way of computing specific gravity would be density of your sample over the density of a standard spec graph. And then it is unitless. So there are 3 methods of determining specific gravity. In pharmacy, we have pycnometer method, Morse, Westphal balance, and then hydrometer method. So ang pycnometer method, this is your pycnometer. You demonstrate ko naman, I think i-demonstrate ko to sa inyo during your physical pharmacy lab, how to use the pycnometer. And then another one, ito na sa baba, this is your Morse Westphal balance. It's an old method of measuring spec graph, pero hindi na siya masyado ginagamit kasi unreliable ang results. Mas ginagamit ang pycnometer method. Okay? And then the last one, we have your specific volume. Specific volume, it is computed as a reciprocal of specific gravity. So 1 over spec graph para makuha ang specific volume. So yan siya for our introduction. So next part, let's have the different states of matter. So what I'll be including here are just the important points that you need to know about the different states of matter in relation to pharmaceutical sciences. So as mentioned earlier, tatlo lang tayo. We'll only discuss the three physical states, the gas state, the liquid state, and the solid state. Okay, so I'll start with the first one, your gas state. So pagdating dito sa gases under physical pharmacy, the important thing here is all about or the important thing here is that you should know about the different gas laws. So by description, first of all, gases, they have high kinetic energy that produces rapid motion. They are held together by weak intermolecular forces, and they are capable of filling all available spaces. They are also compressible, unlike your solids. So I'll skip this part about the kinetic molecular theory of gases because I'll proceed to the major part of our lesson about gases, which is all about the gas laws. So first, among your gas laws, we have the Boyle's law or Boyle's law. So for Boyle's law, it's also known as your Marriot's law. Now, in pharmacy, I remember the mnemonics bote, capre, and Gary V. Bote, capre, Gary V. So ano bang significance ng mga mnemonics ko na to? So itong bote, capre, Gary V, it gives me what are those parameters in those gas laws na constant. So for example, for Boyle's law, bote, the constant parameter here is temperature. Okay, so in Boyle's law, it expresses the relationship between pressure and volume at constant temperature. Constant ang temperature, so the pressure and volume under Boyle's law varies. So it is said daw under Boyle's law is that pressure and volume are inversely proportional with each other. If you increase the pressure towards the gas, the volume decreases, like in this illustration, and vice versa. So inverse ang relationship for pressure and volume for Boyle's law. Constant is temperature. Next. Okay. Next, we have your Charles law. For Charles law, I remember the mnemonic capre. Okay? Capre. Pre stands for pressure. In Charles' law, it expresses the relationship between volume and temperature at constant pressure. So it is said in Charles' law that the relationship between volume and temperature is directly proportional. It means that if you increase the temperature towards the gas, the volume increases. The formula it's V1 over T1. It is equal to V2 over T2. Charles' law. Okay, next. After Charles' law, we have your Gay-Lussac's law. For Gay-Lussac's law, I remember the mnemonic Gary V. So under Gay-Lussac's law, the constant parameter here is your volume. So under Gay-Lussac's law, it expresses the relationship between temperature and pressure at constant volume. So it is said that if the temperature is increased, the pressure exerted by the gas in its container also increases. So directly proportional. Formula, it's P1 over T1. It is equal to P2 over T2. Okay? So bote, capre, Gary V. So those are the first three gas laws. The fourth one, we have your combined gas law. Your combined gas law, it provides a convenient expression for performing gas law calculations involving the most common variables: pressure, volume, temperature. So in pharmacy, ginagamit natin to siya to compute when the 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 values for the three parameters varies from scenario 1 to scenario 2. The formula is P1 V1 over T1 equals P2 V2 over T2. Okay, next, the next gas law, we have the ideal gas law or the ideal gas equation. The formula, it's PV, it is equal to nRT. Your P stands for pressure, volume for V, and here stands for the number of moles of gas. Baka nakakalimutan nyo na how to compute for moles. Moles, it is computed by dividing grams over molecular weight. Next, the R here, it represents your gas constant. So remember the formula, remember the value 0.08206 liter times ATM all over mole times Kelvin. And then the last one, temperature. In temperature, it is always noted here that it should be in absolute temperature. Pag sinasabi nating absolute, it is referring to kelvins. Dapat i-convert siya to Kelvin. So to convert in pharmacy, you need to add the value of 273.15 to your degree Celsius para makuha ang Kelvin. Actually, in all gas law problems, para safe daw, mas maayo na i-convert siya to absolute temperature in Kelvin. Now, sometimes in problems, it would state to you that ang computations, it should be done at STP. Bang ibig sabihin natin ng STP, it's standard temperature and pressure. It is stated here that the temperature, it's 0 degrees Celsius, pero it should be converted man to absolute temperature. So 273.15, pressure is at 1 atm, and standard temperature and volume happens at a volume of 22.4 liters. So yan siya for ideal gas law. Okay, next, we have your real gas equation. Your real gas equation, it's also known as your van der Waals equation. So the difference lang between the two equations from the previous one is that there is the addition of this variables here, an square over v square and nb. So an square over v square, it accounts for the intermolecular attractive forces, and b accounts for the incompressibility of the molecules. Pero in my case, for your case, I will not anymore dwell on this one for the real gas equation. Next, important one, we have your Raoult's law. Your Raoult's law, it is an equation that expresses the lowering of vapor pressure. It's actually under colligative properties, which will be mentioned later. So tandaan lang natin, Raoult's law, related siya to vapor pressure. Next, we have your Henry's law of gas solubility. Henry's law, it expresses the relationship between pressure and gas solubility. So the higher the pressure, the higher is the solubility of the gas. Henry's law. Okay, next, the last two laws, last three, we have your Dalton's law of partial pressure. According to Dalton's law, The total pressure of the gas is equal to the sum of the partial pressures of each gas. Graham's law, it is stated here that the rate of diffusion of the gas and the speed of the gas molecules are inversely proportional to the square root of their density. Okay, and the last one, the last gas law, we have your Avogadro's law. According to the Avogadro's law, the volume of a gas maintained at constant temperature and pressure is directly proportional to the number of moles of the gas. Formula, it's N1 over V1 equals N2 over V2. So, yun lang sila for our gas laws. So, I'll not anymore elaborate on these sample questions. You can take a screenshot. Pero ano lang, just a review. So, we had discussed about the different gas laws. We started with Boyle's law. So, Boyle's law, Charles' law, Gay-Lussac's law, Bote, Capre, Carivi, mnemonics para matandaan ninyo ang constants, and then followed by your ideal gas equation and real gas equation or van der Waals, then followed by your Raoult's law, Henry's law, your Graham's law, your Dalton's law, and then your Avogadro's law. So kindly refer na lang to your handouts regarding those different gas laws. Okay? Sige, next. So we are done with your gases. The next state of matter, it's a subtype of your liquid state. It's called your plasma or your mesophase or liquid crystals. So medyo short lang talaga to siya. Subtopic lamang good siya. So your liquid crystalline state, it's also known as your plasma state. Plasma state, also known as your liquid crystals or your mesophase. It is the intermediate state between the solid and liquid state. So this type of physical state of matter, it behaves like liquids and solids. It behaves like solids in terms of they have an ordered arrangement. It behaves like a liquid in terms that it flows like a liquid. So the person who was credited for discovering or studying your liquid crystals was Friedrich Breinitzer. He was the one who began the study of liquid crystals. So particularly, he observed it using the chemical cholesterol benzoate. So si Friedrich Breinitzer, liquid crystals. Okay, now these are the different characteristics of your liquid crystals. Again, intermediate siya between solid and liquid state. So, ibig sabihin nito, your liquid crystals have the properties of both solids and liquids. So, the three characteristics are, they have a rod-like structure, they exhibit rigidness of the long axis, and they are strong dipoles or are easily polarizable substituents. So because of being a strong dipole, it is said that your liquid crystals are capable of conducting electricity. Like in the case of your LCD. Your LCD stands for liquid crystal display. So it's capable of conducting electricity because of its polar property. Okay, now there are three types of liquid crystal: nematic, smectic, cholesteric. Nematic, smectic, cholesteric. So from nematic to cholesteric, the opacity of the liquid crystal increases. It is said that as the degree of molecular ordering increases from nematic to cholesteric phase, the liquid becomes more opaque. Okay, so let's describe what are describe tayo these three types of liquid crystals. First one, your nematic liquid crystal. It is also known as your thread-like liquid crystals. They are mobile in three direction and they can rotate in one axis. Yun lang important sa kanila. Nematic. Okay? Next, smectic, the second type. Smectic, also known as your soap-like or grease-like liquid crystals, and they are mobile in two directions. They can rotate in one axis. Now, kung compare nimo ang nematic versus smectic, it is said here that your nematic is mobile in three directions, smectic mobile in two directions. So my way of memorizing it is by syllables. So for nematic, ang mnemonic ko nito kay based on syllables. Ne, ma, tik. So tatlo syllables. So therefore, mobile in three directions. Smectic, smek, tik. So mobile siya in two directions. Yan ang way of memorizing nako. Okay? Nematic, thread-like, mobile in three directions. And then lastly pala, molecules are free to rotate or slide past one another. For smectic, mobile in two directions, soap-like or grease-like, they cannot readily slide past one another, unlike your cholesteric liquid crystal. By the way, ang smectic liquid crystals, it is the type of liquid crystal that has application in pharmaceutical sciences. Muna siya ang well-studied because it has an application in pharmaceutical sciences. Your smectic liquid crystal. Okay? And then the last type of liquid crystal, we have your cholesteric liquid crystal. Cholesteric is a special case of nematic type. Molecules are directionally oriented or stacked in a helical pattern with each layer rotated at a slight angle. Yun lang, cholesteric. It's the most opaque among the three types of liquid crystal. Okay? Sige, next, we have the formation of liquid crystals. There are two ways by which liquid crystals are formed. It's either by heating or by the action of certain solvents on solids. If it is formed via heating, it is what we call as your thermotropic liquid crystal. But if it is formed via the action of certain solvents on solids, it is what we call as your lyotropic liquid crystal. Lyo meaning solvent. Okay, thermo meaning heat. Sige, next. The last slide for liquid crystal, these are the properties of your liquid crystal. Yung kanina, characteristics lang yun. This time, the properties of your liquid crystal. First property, liquid crystals are mobile. So they exhibit mobility again because they exhibit or they have the flow properties of your liquids. The second property of liquid crystals is that they demonstrate birefringence. Birefringence, also known as the double refraction of light. Ibig sabihin nito, when a light is shined towards a birefringent material, yung ray of light is separated or it is decomposed into two rays. Double refraction. A characteristic of liquid crystal. A property of liquid crystals. Sige, those are the important things about the liquid crystalline state. Okay, so the next one we have, or our second to the last topic for physical pharmacy, it's about the liquid state. And ito yung medyo bulky sa ating lesson. So liquid state. So the characteristics of your liquids, they take the shape of the containers that hold them. They possess less kinetic energy than gases and are denser than gases. They occupy a definite volume and is fixed by its temperature and pressure. Unlike gases, they are incompressible. Okay. Now, under liquid state, an important property of your liquids is that they exhibit viscosity. So when we say viscosity, it is defined as the resistance to flow. So in terms of intermolecular forces, the higher the intermolecular forces present, the higher is the viscosity of that liquid. So a higher temperature has the tendency to break the intermolecular force. It will break down the intermolecular force, thereby decreasing viscosity. So that's why ginapainit ang ubang liquids, ang ubang viscous liquids. Okay, next, about the topic on the liquefaction of gases. When we say liquefaction, it is the process by which your gas is converted to a liquid. A gas is converted to a liquid. Now, there are two important properties necessary for the liquefaction of gases. You need to remember or need to identify the critical temperature and the critical pressure of that gas para siya maging liquid. So what is critical temperature? It is the temperature at which no amount of pressure will cause the gas to liquefy. Okay? And then for critical pressure, it is the minimum amount of pressure required to liquefy a gas at critical temperature. Now, how to best understand your critical temperature? Let's say, for example, we have carbon dioxide here. It is said that carbon dioxide has a crit temp of 304 degrees Celsius. So ano bang relevance nito? 'Di ba? Para ma-liquefy ang gas molecules are described to be free moving molecules. So para maging liquid sila, dapat yung molecules, dapat they should become closer together. So ibig sabihin nito, para maging closer sila to one another, kailangan ng mas malamig na temperature at kailangan din ng higher pressure so that the interaction between them increases. So for critical temperature, para ma-liquefy ang gas, tandaan natin na dapat yung value kung saan mo siya i-expose na gas, it should be lower than the crit temp para ma-liquefy ang gas. For example, if I were to ask you, the critical temperature is 304, pero let's say you expose carbon dioxide to 303 Kelvin. Will the gas be liquefied or not? So the answer should be yes. If it is less than the crit temp, ma-liquefy ang gas. However, if you expose that gas to 304 Kelvin, okay, 304 Kelvin, which is the critical temperature, according to the theory, if it is equal or greater than the crit temp, dili ma-liquefy ang gas. So pag 303, pwede siya ma-liquefy. Pag 304, dili siya pwede ma-liquefy. How about critical pressure? Critical pressure is 72.9. So when we say crit pressure, it is the minimum amount of pressure needed. So ibig sabihin nito, dapat minimum of 72.9 para ma-liquefy. Pwede ka sumobra, pero hindi ka pwedeng bumaba sa value. Kaya kung bumaba ka, the gas will not liquefy. So para ang gas ma-liquefy, ma-turn siya into a liquid state, kailangan ma-satisfy both critical temperature and critical pressure. Kaya kung dili ma-satisfy masing isa, like for example, kung crit pressure lang or crit temp ang wala, dili ma-liquefy ang gas. So dapat both talaga, crit temp and crit pressure ma-satisfy para ma-liquefy ang ating gas. Okay? So next, what are the three methods of liquefaction? We have Faraday's, Lindy's, and Claude's method. This is just a definition lang ha. So when we say Faraday's method, it's a method used to liquefy gases whose critical temperature is just above or just below the atmospheric pressure. Above or just below atmospheric pressure. Next, Lindy's method. This method compresses the gas first to 200 atmosphere, which is then allowed to pass through a pipe cooled by liquid ammonia. Yun lang, definition lang talaga to. Lindy's method. And then your Claude's method, first, compress the gas to 200 atm and then allowed siya to pass through a refrigerating liquid which then enters an expansion chamber. The gas is allowed to expand freely through the narrow opening which results to the cooling of a gas. So the difference between Lindy's and Claude's method is that in Claude's method, a gas after cooling, it is allowed to pass through a expansion chamber. Okay? So yun lang for the liquefaction of gases. Next, the classification of your dispersed system. Dispersed system, it's under the liquid state pa rin tayo ha. So there are three types: true solution, colloidal dispersion, and coarse dispersion. So by description, what are they? For your true solution, it is a mixture of two or more components that form a homogeneous molecular dispersion or a one-phase system. So the particle size, it's around less than 1 nanometer lang for true solution. Next, colloidal dispersion, it has a particle size intermediate between that of a true solution and a coarse dispersion. Kung sa true solution, less than 1 nanometer, for your colloidal, it's between 1 nanometer to 0.5 micrometer. Next, the last one, we have your coarse dispersion. Coarse dispersion, they have a diameter size of around greater than 0.5 micrometer. So examples of coarse dispersions are emulsions and suspensions. So bale, yun siya ang magiging topic natin under liquid state. Isa-isahin natin ang mga dispersed systems. So I'll start first with your true solutions. Your true solutions, again, it's a homogeneous mixture of two or more substances. When we say solution, it is composed of a solute and solvent. So review, solute, it is the one that is being dissolved. Solvent, this is the one that dissolves or the dissolving medium. Solute, examples are your non-electrolytes like your sugars. And then for your electrolytes, we have your weak and strong electrolytes. Another one for your solvents, classification of your solvents, we have 4 types. We have protophilic, protogenic, amphiprotic, or aprotic solvent. Protophilic, it's also known as your basic solvent. Protophilic, ibig sabihin nito, they would like to accept or they love to accept a proton. So those are characteristics of your bases. Next, we have your protogenic referring to your acidic solvents. These are proton-donating solvents. So examples are your acids. Amphiprotic, they act both as proton acceptors and donors, like your water and alcohol. And then last one, we have your aprotic solvent. Aprotic, they neither accept nor donate protons. Examples are our hydrocarbon solvents like toluene, benzene, etc. Mga neutral natin na solvents. Okay? Next, dissolution and solubility. When we say dissolution, by definition, it is the transfer of the molecules or ions from the solid state into the solution. Next, when we say solubility, it is the extent to which a dissolution proceeds under an experimental condition. So solubility can be described further whether a solute is saturated, a solution rather is unsaturated, saturated, or supersaturated. Now, next, this is important. How would you describe the solubility of a solute in a solvent? In USP, we describe the following terms to your solute if it will dissolve in a certain amount of solvent. So, very soluble daw ang ating solute if it will dissolve, if one part of solute will dissolve in less than one part of the solvent. Freely soluble siya kapag 1 to 10, soluble 10 to 30, sparingly 30 to 100, slightly 100 to 1,000, very slightly 1,000 to 10,000, practically is more than 10,000. On my end, in my case, ang pag-memorize na ko ani is that I would memorize lang kani, si soluble. Si soluble kasi 10 to 30. Tapos sunod-sunod na yan. Pag alam ko na yung soluble na 10 to 30, sparingly, slightly, very slightly, practically. Tapos sunod-sunod ang value. 10 to 30, 30, 100, 100 to 1,000, 1,000 to 10,000, more than 10,000. So, ginamemorize na dyan ako kay si soluble para mas dali on my end. Okay, next, what are the factors that may affect solubility? First one, temperature. Now, under temperature, we have endothermic and exothermic reaction. What do you mean by endo and exothermic reaction? Endothermic, ibig sabihin nito, if you increase the temperature in your solution, you also increase the solubility of your solute. Pag mas painito ninyo, mas taas ang chances na mas dissolve siya. Pag exothermic, the lower the temperature, the higher is the solubility. So, ibig sabihin nito, pag mas bugnaw siya, okay, mas bugnaw, mas ma-dissolve siya. Okay? Like your calcium hydroxide. Next, another factor, aside from temperature, we have pH. So pH, it involves the concept of critical pH or the pH of precipitation. What do we mean by the word critical pH? So critical pH, okay, so for weak acid and for weak bases, iba-iba sila for weak acid and for weak bases. Kapag critical pH for weak acid, it is the pH below which the weak acid precipitates. Pero kapag critical pH for bases, it is the pH above with which the weak base precipitate. Okay? Below for a weak acid for critical pH, above for bases. Yun ang pH. Next, presence of salts. We have the so-called salting in and salting out effect. Pero I'll not anymore elaborate. And the last one, for factor affecting solubility, we have particle size. So by concept, Ang particle size, the lesser the particle size, the greater is the absorption. The lesser the particle size, the higher the surface area, the greater is the absorption. Kasi mas madali siyang ma-dissolve. So, yun lang for our factors affecting solubility. Ay, meron pa pala. Sorry. Last two, pressure and concentration. Pero wala kay shell application kayo. Alright, next. The next part, we have the colligative properties of solutions. Now, when we say colligative properties, again, it was defined earlier. It is a type of property that depends upon the number of components of the system. If the number of components changes, this property also changes. So, nagabago po ang mga colligative properties nato. So, what are the four colligative properties? We have vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. Moto sila ang upat nato na colligative properties. Okay, so I'll start first with your vapor pressure lowering. It is said, so how to best understand your vapor pressure? So when we say vapor pressure, it is referring to the pressure exerted by the gas molecules when, di ba, for example, magpabukal mo. Di ba, pag magpabukal mo, lagyan nyo ng cover, yung kaldero or what, di ba, eventually yung liquid natin, di ba, mag-evaporate man siya. It will evaporate into gas. Yung gas natin, referring to your vapor, it exerts a certain type of pressure. So, ang tawag natin doon, it's called vapor pressure. Okay? Now, according to the colligative properties, the theory of colligative property, when you add a solute to your solvent, okay, kaning nasa left side, solvent lang ni siya, kaya color blue lang jud siya, water alone. However, on the right side, meron tayong addition of solute, itong color red na plus sign. So, this is your solute, so it becomes a solution. Kaya na naman siya solute. Solute plus solvent becomes a solution. Okay? It is said daw that the vapor pressure of a pure solvent, from a pure solvent to a solution, magbaba. Kaya ang tendency manggod kapag may solute, less ang amount of solvent molecules na mag-evaporate. Okay? Gamay lang ang solvent na maka-evaporate. Kay murag ibara manggod siya sa solute. So, less lang mag-evaporate. Kapag less lang ang vapor na ma-form, lowered po ang vapor pressure. Kaya gamay laman ang gas na mag-exert og pressure. So, that's why sinasabi dito, vapor pressure lowering. When a non-volatile solute is added to a volatile solvent, the solute reduces the escaping tendency of the solvent. So that is why magbaba ang vapor pressure ni solution. Mo na siya ang colligative property. As you add more components, mag-change ang colligative property. But in the case of vapor pressure, mubaba siya, mu-lower down siya kay vapor pressure. Okay? Next, how about for the boiling point? It is said daw that if you add more solute, the boiling point elevates or increases. So what do we mean by this? Let's start by defining boiling point. Boiling point, it is the temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure. Diba? Okay, kung babalik tayo sa dalawang illustration natin, ang ating pure solvent, like your water, it has a boiling point of 100 degrees Celsius. If you add more solute, the tendency is that kailangan ng higher temperature para mapabukal ang ating solvent. kay na may solute. So, ang tendency is that from a pure solvent na 100 degrees, ang ating boiling point kung saan kailang the temperature at which magbukal ang ating solution also increases as well. So that's why mosaka ang boiling point. Okay? So naka-state dito ho that the boiling point of a solution containing a non-volatile solute would be higher than the pure solvent because the solute will lower the vapor pressure of the solvent. So reduced ang escaping tendency ni solvent. So that's why you need a higher temperature para lang ma-evaporate ang atuang solvent. That's why the boiling point increases. Okay, next. Another type of colligative property, it's your freezing point. Freezing point, it's also referred to as your melting point. The freezing point from a solvent to a solution depresses, magbaba ang freezing point. It is said that a solution, solute plus solvent, they have a lower freezing point than that of a pure solvent. Ang pure solvent has like water, it has a freezing point at around 0 degrees Celsius. Pero for solution, solute plus solvent, it will have a much lowered freezing point. O reach ang negative degrees Celsius. So ibig sabihin nito, para maging solid siya, instead of 0, you need to have a lowered temperature para siya maging solid. For freezing point, mo depress siya. And then the last one, osmotic pressure. What do you mean by osmotic pressure? It is the pressure that is needed to offset osmosis, or it is the pressure that is needed to stop osmosis. So what do you mean by osmosis? Osmosis, it refers to the movement of the solvent, movement of water molecules through a semi-permeable membrane from a less concentrated to a more concentrated solution. So, kumbaga ba, kung asa mas gagmay, mas daghag solute, si solvent nato, si water, it has the tendency to go to the more concentrated areas para in an attempt to dissolve or to lower the concentration. Mao na siyang osmosis. The movement of solvent molecules from a lowered concentration or from a less concentration to a higher concentration. So the pressure that is needed to stop osmosis or to prevent osmosis, it is what we call as your osmotic pressure. Now, next, let's talk about the tonicity of solutions. Tonicity of solutions, we have hypertonic, hypotonic, and isotonic. So, I know you had this one, familiar mo ani siguro. Let's start with your hypertonic solutions. These are solutions that have more solutes compared to cell concentrations. So, pag hypertonic, yung solution natin has a much higher solute concentration. So, ang tendency is that the solute from the water from your cells will escape from the cell in an attempt to dissolve the concentration, the salt outside. So the tendency for a hypertonic solution is that when a cell is exposed to a hypertonic solution, the cell will shrink or it will crenate because of the loss of water. Okay? For hypotonic solution, these are solutions that with less solutes compared to cell concentrations. So the cell effect will swell or lyse. So ang hypotonic, ang hypo kasi, ibig sabihin yan, hypo stands for under. So ibig sabihin nito, the solute concentration within the cell is greater than the outside. So ang tendency is that kung asa mas daghan og salt, mas dito ang moagto ang tubig. Okay, so mosulod ang tubig sa cell. So ang tendency, the cell will swell or lyse. It will burst in the process. Okay, mapuno man siya og tubig. However, for the last one, we have your isotonic solutions. Isotonic solutions, these are solutions for which a living cell does not gain nor lose water. So isotonic solution, this is the type of solution that is compatible with our body fluids. So an isotonic solution of sodium chloride has a concentration of around 0.9%. So it will not have any drastic effects to our living cells. Okay, so that's the application of osmosis to the tonicity of your solution. Hypertonic, hypotonic, isotonic. Now, ano ba ang kinalaman ng tonicity of solutions in physical pharmacy? Now, tonicity of solutions is important because when a solution is to be administered to our human body, dapat daw, as much as possible, isotonic para dili siya makakause of irritation or discomfort for the patient. Now, what are the methods for adjusting isotonicity? Kailangan kasi maging isotonic ang solution. So there are two methods. We have the class 1 and class 2 methods. Class 1 methods, it refers to the addition of a solute, addition of a tonicity adjuster. Particularly, ginagamit to siya na class 1 method for hypotonic solution. Hypotonic kay kulang man siya og solute. So you need to add more solute para siya maging isotonic. Examples of class 1, we have the freezing point depression method or cryoscopic method, and then your sodium chloride equivalent method or your E-value method. For class 2, it involves the addition of water followed by dilution with a buffered isotonic vehicle. Ang class 2, it refers to the addition of water para siya maging isotonic. Ang class 1, mag-add kag solute. Ang class 2, mag-add ka og water para maging isotonic. Ang class 1, ginagawa siya for hypotonic, kay kulang makag solute. For class 2, ginagawa siya for hypertonic, kay sobra makag solute, hyperman. So you need to add more solvent or water para ma-dilute siya para siya maging isotonic. Examples of class 2, we have your White-Vincent method. It's the USP recognized method of class 2. And then your Sproul's method. White-Vincent, Sproul's. So first, let's have the first class 1 method, your freezing point depression or cryoscopic method. Ang class 1 method na ito, it involves mainly measuring the freezing point of your solution. It is said that an isotonic solution has a freezing point of around negative 0.52 degrees Celsius. So, ang point ng freezing point depression method or cryoscopic is that you need to add more solute para ang freezing point mo reach siya og negative 0.52. So, dapat mo ang target ninyo, negative 0.52 for the freezing point depression method. Next, for the second class 1 method, we have your sodium chloride equivalent method or your E-value method. So your E-value, it refers to the grams of sodium chloride equivalent to 1 gram of a substance. So the most commonly used class 1 method, it's your sodium chloride equivalent method or E-value method. So actually, this type of method is usually done in 3 to 4 steps. So ang step 1, you need to calculate the amount of sodium chloride represented by the ingredients. Second step, you need to calculate the amount of sodium chloride that would make the volume of the solution isotonic. Step 3, and then step 4. So pero para mas maintindihan nyo good, I'll give you an example. So the sample problem here is that a solution contains 1 gram of ephedrine sulfate in a volume of 100 ml. What quantity of sodium chloride must be added to make the solution isotonic? The E-value of the drug, your ephedrine, is 0.23. So, paano ba ito gawin? Step 1, ang gagawin sa step 1 is that you need to multiply the amount in grams of the drug to its E-value. 1 gram times 0.23. So, you will get 0.23 grams for this problem. Step 2, for step 2, automatic na to always ha. You need to multiply the factor 0.009 to the volume of the solution. Automatic na talaga everyone. For step 2, 0.009, you multiply it with the volume required. In this case, the volume required is 100 ml. So you will get an answer of 0.9 grams. For number 3, for step 3, you need to subtract your answer from step 2 to end step 1. So step 2, 0.9 minus step 1 answer 0.23, you will get 0.67 grams of sodium chloride. So yan siya, ang answer natin. The answer is 0.67 grams of sodium chloride. Now, you may wonder, ano ba ang step 4 natin? Ang step 4 natin, it will apply if your isotonicity adjusting agent is not sodium chloride. In this case, ang ating isotonicity adjusting agent kasi it's sodium chloride. Pero kapag dili siya sodium chloride, dili mo mag-stop sa step 3. You will proceed to step 4. For step 4, simple lang siya. You will get your answer from step 3. Okay, that will be your numerator. You divide it with the E-value of your drug na i-add ninyo as isotonicity adjusting agent. Like for example, kung i-add ninyo dire kay boric acid. So kung boric acid, you will not stop at step 3, you will proceed to step 4. So ang gagawin nyo lang, i-divide nyo lang. Ang E-value ni boric acid, it's around 0.52. So your answer in step 3 divided by the E-value of that drug, you will get your answer. Okay, next, how about your class 2 methods? Your class 2 methods, it involves the addition of water para maging isotonic yung ating hypertonic solution. So to make this one, we have 2 methods, White-Vincent or Sproul's method. The formula for White-Vincent method, the volume of water can be obtained by multiplying the weight in grams of your solute times the E-value times 111.1. Weight in grams times the E-value times 111.1. For White-Vincent. For Sproul's method, it's a simplified version. The difference lang is that it is the value for the weight, it's around 0.3. Usually, ang Sproul's method, ginagawa siya for your ophthalmic solutions or yung ating mga eye solutions. Okay, it is said that the amount, it's around, 1 fluid ounce. So, 0.3. Okay? So, how to solve using your White-Vincent method? Ang gagawin lang talaga, you account for the weight, individual weights, and then you multiply with the E-value, and then 111.1. So, para makuha ninyo yung amount of water. Tapos, if there are more than one solute, ang gagawin niyo is you need to add them. Yung values ng ml para makuha niyo yung total. Okay? So, mo na yung problem. Mo na yung answer. Okay? So, next. So, that's for your adjusting isotonicity, class 1 and class 2. Next, we have the acid-base equilibria. Ano lang to siya? More on review. Arrhenius theory, Bronsted-Lowry theory, and Lewis theory. These are the three theories that are used to differentiate between acids and bases. Acid, they yield hydrogen ions or hydronium ions in water. Base, yield hydroxide ions in water. Bronsted-Lowry, proton donors. Base, proton acceptors. Acids, for Lewis theory, electron acceptors. Base, for Lewis theory, electron donors. Okay. Next, we have pH and Sorensen's pH scale. pH, it is the measure of acidity and alkalinity of a solution. So, kapag 7, neutral. Kapag greater than 7, basic or alkaline. Kapag less than 7, acidic siya. Okay, the pH scale is used in ranges from 0 to 14. 14 most basic, 0 most acidic. Next, we have the following terms, ionization and dissociation. By definition, when we say ionization, it refers to the complete separation of ions in a crystal lattice. Dissociation, separation of ions in solution when the solutions are associated by interionic attraction. Okay, pero actually, similar lang good silang terms. Pero by concept, or by concept, similar sila, pero by definition, i-separate sila. Si ionization, complete separation. Si dissociation, separation lang siya. Okay, next, we have buffers. Buffers, these are solutions that have the property of resisting changes in pH when acids or bases are added to them. The most common type of buffers, they're usually they come in pairs talaga ang buffers, but the usual type is a weak acid with some salt of its conjugate base. That's the most common type of buffer. Weak acid plus its conjugate base. The buffer equation, it is what we call as your Henderson-Hasselbalch equation. It is computed by the formula pH, it is equal to pKa plus logarithm conjugate base over weak acid. Again, it is the most common type of buffer, weak acid plus the conjugate base. Okay. Under buffers, we have the so-called buffer capacity. Other names are as follows: buffer action, buffer efficiency, buffer index, and buffer value. It is defined as the ability of a buffer solution to resist changes in pH when acids or alkali is added. It is said that the buffer capacity has reached its maximum value when the pH becomes equal with the pKa, maximum buffer capacity. Okay, next, let's talk about your interfacial phenomena. Interfacial phenomena, it is referring to the occurrence of a boundary between two phases. Now, there are two types of interfacial phenomena: interfacial tension, surface tension. Simplified, when we say interfacial tension, it is referring to the boundary between two liquid phases. Like for example, oil and water. Oil and water will not mix with each other. So the boundary between oil and water, ang tawag natin dyan, interfacial tension. For surface tension, it is referring to the boundary between two opposite phases. Like for example, between solid and liquid, between liquid and gas. Surface tension ang tawag natin dyan. Like for in this example. Okay. Next, we have your surfactants. Surfactants, they're also referred to as your surface active agents. These are agents that lower the surface free energy. In other words, in emulsions, ginagamit siya to lower interfacial tension. Now, surfactants are described using the Griffin HLB system. The higher the HLB value, the more water soluble or the more hydrophilic it is. So mo na siya ang ato ang mga different types of surfactants with their corresponding HLB value. Ang pinakauna, your anti-foaming, 0 to 3. Water in oil, 4 to 6. Wetting agent, 7 to 9. Oil in water, 8 to 18. Detergent, 13 to 15. Solubilizer, 10 to 18. Ang nakalagay sa inyong handouts, it's different. So, kani siya ang correct. Okay? So, next, cohesion, adhesion. Again, cohesion between like molecules. Adhesion, unlike molecules. It was mentioned at the first part of our lecture. Next, I'll not anymore elaborate this one. Anisad. So, moto siya for our true solutions. Don't worry for the rest, short na naman po. Dako lang jud, bulky lang jud for our true solutions. The next type of a dispersed system, we have your colloidal dispersion. Colloidal dispersion, it is a type of dispersion that has the particle size found between a true solution and a coarse dispersion between 1 nanometer to 0.5 micrometer. Now, for colloidal dispersion, we have three classes: lyophilic, lyophobic, association colloids. So by simple definition, what do we mean by these? Lyophilic, these are solvent-loving colloids. They are spontaneously described and thermodynamically stable. Lyophobic, it's the opposite, solvent-hating, non-spontaneous, thermodynamically unstable. And then the last one, your association colloid. This involves the use of surfactants and my formation of what we call as your micelle. Yun lang ang things to know for the three types of colloids. Okay. Now, methods of preparation of colloid dispersion. We have three: condensation, deflocculation or dispersion, and baptization. Condensation, from small, i-condense siya to a larger particle, colloidal particle. Deflocculation or dispersion, opposite siya. From a bigger particle, maging smaller, colloidal particle siya. And then baptization, same principle of salting out. Higher concentration of electrolyte will cause the precipitation of your colloidal particles. Next, properties of your colloidal dispersion. Now, there are three properties of colloidal dispersion: optical, kinetic, and electric. Optical, kinetic, electric. For optical property, we have the Faraday-Tyndall effect. When we say Faraday-Tyndall effect, it's the ability of your emulsion or your colloid rather to scatter or disperse light. So for example, in a foggy street, so ang tendency for a colloid kay i-distribute niya towards the different molecules ang light. Unlike sa solution na mo, pass through lang siya. Okay, that's the Faraday-Tyndall effect. For kinetic, we have your Brownian motion. Brownian motion, this refers to the constant motion of your colloids. Constant movement of your colloids. Brownian motion. Okay, and then for electric property, we have the Nernst potential, aka electrothermodynamic, but an important property would be your zeta or electrokinetic potential. Ang zeta potential in application to pharmacy it is that kapag mababa daw ang zeta potential for a colloid, it results to flocculation, which is an example of instability. So dapat taas ang zeta para siya maging stable ang colloid. Okay, and then the last one for your liquids, we have your coarse dispersion. Particle size is greater than 0.5. Examples are suspensions and emulsions. So, particularly lang talaga dito ang sa physical pharmacy, we'll only be talking about the stability problems. So, by definition, the stability problems among your coarse dispersion are the following. For phase inversion, it's a problem among your emulsion, wherein from oil in water, maging water in oil siya, or vice versa. Cracking, it's the total separation of the two phases. Kapag phase inversion or cracking na daw ang ating coarse dispersion, i-dispose na ang ating coarse dispersion kay wala na siya di na siya stable. Creaming and sedimentation, they are often interrelated. Ang creaming, it's the upward movement of the internal phase of the emulsion. Upward movement, ang creaming. Sedimentation, it's the downward movement of the internal phase of the emulsion. Aggregation and coalescence, they come together wherein they are often defined together kay ang aggregation, globules tend to come together but do not fuse. Pag coalescence, globules come together but they fuse. So muna siya ang difference between aggregation and coalescence. That's why they are interrelated along with your creaming and sedimentation. Okay? And next, sorry pala, last part na ito siya for liquids. Rheology. When we say rheology, it refers to the study of flow. Study of flow. Now, rheology talks more about the viscosity of a material. Viscosity refers to the resistance of flow. The opposite of viscosity is fluidity. Okay, so viscosity in computations can be obtained using the formula F over G. F represents your shear stress, G represents your shear rate. Now, there are three types of viscosity: absolute, kinematic, relative. Ang absolute viscosity, muna siyang common type of viscosity, it is measured in units of poids. Kinematic, it is measured in the unit of Stokes or centistokes. Para makuha ang kinematic, you divide the absolute viscosity by the density of your material. Absolute over. For relative viscosity, you just, it's the comparison between the viscosity of solution 1 and solution 2 para makuha ang relative viscosity. Okay? So, let's talk about the types of flows according to rheological concepts. Now, there are two main types of flow. We have Newtonian and non-Newtonian flow. Newtonian flow, they have a linear relationship between shear stress and shear rate. Ang important lang dito kay Newtonian flow is that this type of liquids exhibit constant viscosity with increasing rate of shear. Ibig sabihin nito, kahit kahit or no matter how much shear stress you apply or how much force you apply, kahit i-shake nyo pa yan or what, its viscosity still remains constant. Walay change in its viscosity. However, for a non-Newtonian flow, there are changes in viscosity as the force you applied change. Okay, for non-Newtonian, we have two subtypes, shear-dependent and time-dependent viscosity. Under shear-dependent viscosity, we have your plastic, pseudoplastic, dilatant. Ang plastic flow, it's a type of flow wherein you need to overcome the so-called yield value para mo-flow ang atoang liquid. So, other name of your plastic flow, it's also called your Bingham bodies. So, it is demonstrated particularly in ointments, ang plastic flow. Next, for your pseudoplastic flow, it's also known as your shear thinning system. From the name itself, shear thinning, as you increase the rate of shear or as you increase the force that you apply, magbaba ang iyahang viscosity. Mas o less viscous siya. Like for example, ketchup and mayonnaise. As you shake the container from a viscous type, magiging fluid type siya for pseudoplastic. For dilatant, also known as your shear thickening, it's the opposite of your pseudoplastic. If you increase the shear rate, mas mo thicken out ang atuang preparation. Like for example, starch paste, whipped cream. Dilatant sila. Okay? Now, under your time-dependent, under your non-Newtonian, so we have thixotropic and rheopectic system. So, thixotropic, it's the counterpart of your pseudoplastic. For your rheopectic or rheopexy, it's the counterpart of your dilatant. Okay? Thixotropic, gel, sol, transformation. Rheopectic, sol, gel. Okay ha? So, ang ginatandaan lang ako diri kay si rheopectic. Si rheo, R, ang sunod ni R sa alphabet kay letter S. So, RSG. Rheopectic, sol, gel. So, ibig sabihin the other one, katong thixotropic, gel, sol. Okay? So, wala siya for non-Newtonian flow. So, that's for your liquids. For solids, konti na lang talaga to siya. So, solids, the last topic, the last area for pharm. This is the physical state characterized of having fixed shapes. They are nearly incompressible. Their movement, unlike your liquids na through flow, ang movement of our solids is through vibration in fixed positions. There are two types of solids, crystalline and amorphous. So I'll start with the first type, amorphous solid. They're also known as your super-cooled liquids or your gases. They are non-crystalline, they have no definite order or arrangement, and they are considered to be isotropic. Ibig sabihin nito, random lang sila. Random. They have different properties at random arrangement. Isotropic. Okay? Whereas for crystalline, it's the opposite. Ang crystalline natin na solids, they are described to be anisotropic. Okay? Anisotropic. Alright. Now, for crystalline, we have different types of geometric forms or shapes. So these are the 7 types of shapes. We have cubic, tetragonal, triclinic, orthorhombic, hexagonal, monoclinic, trigonal. Now, listed on the PowerPoint are examples of some common solids na may okay, so these are examples of solids na what do you call this one? na may common shapes. Like for example, cubic. The shape of your sodium chloride is cubic. For tetragonal, one example would be urea. So akong mnemonic ani para matandaan ko na ang urea, tetragonal shape, kay ikaw na ako number of letters. Urea has 4 letters, so tetragonal akong mnemonic. Hexagonal, example is iodoform. Para ma-remember na ko na ang hexagonal or ang iodoform is hexagonal, I write it as I2 form. Okay? I2 form. So, I2, if you add 4 and 2, 6. So, kaya siya hexagonal. Muna kong way of remembering. Rhombic, iodine, monoclinic, sucrose, wala kay mnemonic. For triclinic, an example would be boric acid. Ang chemical formula ni boric acid is H3BO3. So, H3BO3, may dalawang 3, triclinic. Ako ang way of remembering. Okay? So, mana siya. By the way din pala, I would like to re-emphasize ang amorphous, isotropic, ang atuang crystalline, anisotropic. When we say isotropic pala, sorry, mali pang definition ko. It exhibits uniformity in all directions. Uniformity in all directions. Amorphous. Okay? Whereas for crystalline na anisotropic, it exhibits non-uniformity or dependence in direction. So, kumbaga, naga-differ ba? Unlike, naga-differ siya kapag crystalline. Okay? Sige. Next, properties of your solids. Some solids exhibit polymorphism. When we say polymorphism, it's the phenomenon wherein a solid may exist in more than one crystalline form. Like for example, your theobroma or cocoa butter, which is a suppository base. There are several forms of theobroma or cocoa butter, but the most stable would be the beta one. The beta one, it has a melting point of 34.5 degrees Celsius. So, ibig sabihin nito, it will remain solid at room temp, pero kapag at body temp, magiging or magmelt siya. On the other hand, we have your solvates, also known as pseudopolymorphs. These are crystals having solvent molecules. Yung may water good na content times 6 water, times water, yung may water na content, solvates. Pero kapag water ang content niya, particularly, it is what we call as your hydrate. Okay? Pero different solvents may apply, pero kapag water, hydrate. Now, the last part of solids, it's under micromeritics. So when we say micromeritics, it's the study of small particles. This is important, particularly in powders and granules. So micromeritics, what are the methods of determining particle size? Now there are 4 methods. First one, we have your optical microscopy. From the name itself, the use of a microscope to measure the individual particle size. Now, ano ba ang tinitingnan under optical microscopy? We have ferret, Martin, and projected area diameter. Now, what is Martin diameter? Ang Martin diameter, tandaan nyo lang si Martin, mahilig siyang makitunga. Mahilig siyang mag-divide ng pagkain. So, the Martin diameter, it is the distance between two opposite ends. So, itungaon niya ang particle size ba? Martin diameter. Ang ferret diameter, it's the distance between the two opposite ends. Kaning kung naka-bold or kaning dark kind na shape, this represents your powder ha. Kaning circular shape, this represents the eyepiece sa microscope. So yung dulo to dulo ng powdered particle, it's the ferret's diameter. Martin's, it is the distance that will divide the image into half. Projected area diameter, it's the size of the particle that will be enclosed within the eyepiece of the microscope. Projected area diameter. Okay, next we have your sieve analysis. So sieve analysis, remember lang ha that this is the USP method of determining particle size. So ang ginagawa, your powders are passed through sieves, and sieves are identified or marked with a sieve number or a mesh number. Next, we have your sedimentation method. Sedimentation method, it measures the sedimentation rate using an Andreasen apparatus. Muna siyang Andreasen apparatus. It is said daw that if a particle has a greater size, mas mabilis siya mag-settle down, mas mabilis siya mag-sediment. So the principle of sedimentation, it's under Stokes' law. And then the last one, we have your automatic particle counters. Examples are your Coulter counter, Hayek or Royko, and Gell-Mann counter. I'll not anymore elaborate on this one. But basta tandaan nyo lang, the USP method, it's your sieve analysis. Okay, next, we have the concepts of particle volume and particle density under micromeritics. Particle volume, it is referring to the space occupied by the powder. Now, there are three types: true volume, granule volume, bulk volume. True volume, it's the volume occupied by the particle. Your granule volume, it's Vg. It is the true volume plus the intra spaces. Your bulk volume, it is the granule volume plus the interspaces. So, kumbaga, true volume plus intra plus inter for bulk volume. For density, meron tayong three types as well: true, granule, bulk. Depende sa volume na ginamit ninyo. Kapag true volume, true density. Granule volume, granule density. Bulk volume, bulk density. Okay, next, we have your porosity. So porosity, it is measured in percentage. That is why pag-compute ng porosity, it is always multiplied by 100. Porosity, it is the measure of the total voids or spaces in the particle. You just study this formula for your upcoming exam for CE2 under pharm. Porosity. Okay? So next, the last one, under micromeritics. Under micromeritics, aside from studying porosity, we also study the different flow properties of powders. So how would you be able to measure the flow properties of your powders? We make use of these three types of formulas: angle of repose, Carr's compressibility index, and Hausner's ratio. Angle of repose, it is obtained by computing tangent -1 in your calculators, shift tan height over radius. Ang ginagawa for angle of repose kay gina-measure ang height na gina-occupy ng cone, ng pile of powder, at saka ang kanyang radius. Height over radius. Tangent -1 height over radius. For Carr's compressibility index, at saka ang Hausner's ratio, ginagawa siya using a graduated cylinder. Kasi ang ginagawa kasi, or ang nangyari kasi in real life is that in the manufacturing setting, pag maglagay mo powder in a graduated cylinder, ang powder manggod na magunay hangin within itself. Na siya sa mga spaces ba. So after which, ang ginagawa sa powder sa graduated cylinder is that ginatap siya ba. It is tapped down. After tapping down, magbaba ang yang volume. Ang prior volume, it is what we call as your VI, or your initial volume. The tapped volume, it's what we call as your VF, or the final volume. Kaya sa Carr's and sa Hausner's ratio, meron tayong VI and then VF. Ang VI, the initial volume occupied by the powder. VF, the final volume occupied by the powder. So, muna siyang formulas na to. Okay, so mo na siyang example of a problem. So, okay, so tapping down, you can compute this problem using Carr's and Hausner's ratio. So, initial volume is 65, pero after tapping down the cylinder, na-reduce siya to 65 ml. So, ang VI nito kay 65. Ang VF this time, it's minus 15 man. Kay reduced by, nabawasan siya 15 ml. So, therefore, the VF, it's 50. So, makuha ninyo siya. VI is 65, VF is 50. So, makompute nyo siya using these formulas. Okay, and that's it for our lecture for pharm. Sorry ha, gihuman na lang dyan na ako para wala na yung. So, things to remember, murag summary ni siya. Things to know about what are the different equations that you need to know. Vance-like buffer capacity equation, Fick's law, diffusion, Stokes, sedimentation, Michaelis-Menten, diffusion, active diffusion, Noyes-Whitney, dissolution, Van 't Hoff equation, ano siya. Okay? And then the rest. So, makita yan siya sa inyo handouts. So, that concludes our session for pharm. So, actually, yeah, it's already 9:30 na. So, actually, dismiss na tayo dapat. Pero, actually, meron akong activity sa inyo. So, ganito ang mangyari ha. For our second session for physical pharmacy on April 13, okay, April 13, instead of meeting you via Zoom, I'll meet you face-to-face for a by-pair oral recitation. Kumbaga, ang gagawin lang for oral recitation kay mura lang siyang exam, kay murag namoy choices, pero you work as a pair. By twos tayo sa ating oral recitation for our next meeting. However, di ba I mentioned kanina meron tayong activity. So our
recording stopped.
So our activity after today, since we are done with our lecture, it's via Kahoot. So ganito ang mangyari. The top 10 placers, ang top 10 placers natin ha for our Kahoot, they will not anymore do the oral recitation. Bale, exempted na sila. They will get the perfect score and I will not meet them anymore for our next meeting. So actually, pwede na mo mag-leave sa atong Zoom meet. Pero kung gusto pa niyo mag-appeal sa atong Kahoot, okay ra pod.